Make sure you pay attention because, like I said, this is an end of level, similar to an end of level test problem. So it says write a function that has triple the amplitude and is decreasing the midline by 4 units. Wouldn't that be a shift of up and down? So that's got to go on the outside of your function, not inside your parentheses. That shift left and right. So be really careful. So I saw a few people get it wrong. So we would write f of x is equal to, it's going to be a computer-generated test, so then triple the amplitude. So instead of having an amplitude of 3, it's going to be up at 9. So 9 sine. Now, amplitude change and a shift down will not affect your period, right? Which this isn't period. This is the number of cycles from 0 to 2 pi, right? Remember that. Period equals 2 pi divided by b, right? Just making sure that we don't think that's the period. But anyways, all right. And then we're going to decrease the midline by 4 units. That's all you have to do. Minus 4 on the outside. Yay. Yeah, what's today? No. Once again, on the test for these formulas, I will give them to you. Yeah. But you just need to know how to apply them. You'll need to know your identities, but any formula I think I'll give to you. I'm not sure if I'm gonna talk to Mr. Roberts. I'm not sure if I'm gonna say use this formula. I think we might just list out all the formulas. Does that make sense at the top? And then you can use them knowing how to apply them. But I'm sure we won't, so. Okay, it says solve. So now we're going to apply, looking at this, so normally everything we've solved so far has just been x and x. But notice in this one, the problem is we have one cosine x, one sine of 2x. You can't just solve this one unless they're the same type of variable. So the same thing in the parentheses. So we would say to ourselves, oh, I remember this is a double angle. So I'm going to rewrite it as this, because then we're all good. So this is the same thing as 2 cosine of x. Plus, instead of writing it as sine of 2x, we're going to write it as this. So it'll be plus 2 sine of x, let's use the right variables, cosine of x. Now we can solve it because now they all have just x's. So everybody see the benefit here? Yeah, u is interchangeable, so it could be as long any variable. So 2 theta, it could be splitting up, same thing. Everybody good? So now do you see, how would we solve this one? We always try doing what first? Factoring. What can we factor out? A 2 and a? Good. A 2 cosine x. So divide by 2 cosine x. Divide by 2 cosine x to see what's in your parentheses. So left right there is a 1 plus sine of x. And now look at it, guys. We have it very easily factored here. So now you can set each of those equal to 0 and solve. So you'll set 2 cosine x equal to 0. Divide by 2, divide by 2. So when does cosine of x equal 0? Now remember, that only happens at certain spots on our unit circle. So that's over 0 cosine x, right? Yeah. Over 0 up 1, over 0 negative, oops, over 0, over 0 negative 1. So doesn't it happen at pi halves and 3 pi halves? So there's our two solutions. And it doesn't say over a certain interval, so it'll be pi halves plus 2 pi n, because cosine and sine have a period of 2 pi. 3 pi halves plus 2 pi n. If you can't read that, that's 3 pi halves, sorry. There's our two solutions here. And now we'll solve for x here, so we'll subtract 1. So we would have, when does sine of x equal negative 1? Think of your xy chart. That's negative 1 of 0, right? So doesn't that happen at pi? Sine is, oh, that's wrong, right? The sine is y, so I'm not right. Good catch. So over 0, negative 1. So isn't it at 3 pi halves? And we've already listed that one out as one of our solutions, so we wouldn't necessarily need to list it out again. So our answers are pi halves plus 2 pi n, 2 n pi, or 2 pi n, whatever we want to write, and then 3 pi halves plus 2 pi n. You wouldn't need to, but if you did, that would be fine, because it did happen twice, but really, those are our solutions at those places. You don't even need to see multiplicity of 2. Okay, questions on that? Okay, awesome. Let's do this one. It says, given this, what's the amplitude, period, max and min, the x-intercept? So we're going to want to graph this. Well, it's quadratic. It's a cosine that's quadratic. We don't know how to graph quadratic cosines. We only know how to graph cosines. So what you would recognize is say, let's see what's going on here. Let's factor it first to see if we can get this a little bit prettier.
Was the amplitude, if you factored it, was the amplitude 34?
We're gonna have to see. So let's factor it and see what happens. Can we pull out a 2?
Yeah.
So then divide by 2, divide by 2. So then left is 2 cosine squared x minus 1. Now you would have to recognize from that that is the same thing as 2, and that is the same thing. That was one of our double angle formulas. That is literally exactly the same thing as that, which is more graphable because it's not quadratic anymore. So everybody sees.
Yeah.
So instead of that, we're going to write, well, that is the same thing as cosine of 2u, or 2x. Let's call it x. And now we can graph that. So we would say, okay, cool. Up 2 is our amplitude, down 2. And then our period for cosine is 2 pi divided by b. Our b is 2. So our period's pi. So then for cosine, we go over 1, 2, 3, 4 tick marks. And that would put us at pi, because that's one period, right? Everyone remember back to graphing? Then over 1, 2, 3, 4 will put us at 2 pi. Because we'll graph usually 2 cycles for cosine, right? So is anybody lost or anything? Do I need to slow down?
So that,
Okay, so then halfway between will be, let's keep labeling the axis here. Pi halves, won't this be pi fourths? 1 pi fourths, 2 pi fourths, won't that be 3 pi fourths? 4 pi fourths, which is right, because that simplifies to be pi. 5 pi fourths, 6 pi fourths, which is 3 pi halves, and 7 pi fourths. And then remember what happens with cosine. Cosine starts at the max 0, min 0, max. And it's positive 2. So max 0, and the next point's the min, the next point's the 0, the next point the max. There's one cycle. Zoom, zoom. So max 0, min 0, max for cosine. And we've graphed that. So now it says, what is the amplitude? Now we can answer it, isn't it 2? Our period is pi. Our maxes we're gonna actually write all of our maxes as points. So this is how we're gonna write our maxes, you guys. So our maxes happen on an interval from 0 to 2 pi, 0 up 2, correct? Another max would be over pi up 2, xy. And another max would be over 2 pi up 2. Our mins happen at the lowest points on an interval from 0 to 2 pi. Our min happens at pi halves down 2 and at, did I miss it? No, at 3 pi halves down 2. And that's it. Those are our mins right there and right there. And we've done our maxes up here. There was 3 maxes on an interval from 0 to 2 pi. Yeah, and our x-intercepts. Our x-intercepts are over pi 4 sub 0. Pi 4 sub 0. And we know this is continuing forever, so there's many of these. It's just we're taking the max and mins on an interval. Does that make sense? Okay. And then over 3 pi, our 0 is over 3 pi fourths. Look, you can just look and see where it crosses. Of 0. Another 0 is 5 pi fourths of 0. And that's it. Nope, 7 pi fourths of 0 also. I'm going to write it right here. 7 pi fourths of 0. So now we've listed out all of our x-intercepts on an interval from 0 to 2 pi. So just making sure we understand. So it wasn't hard, but it was just recognizing what to do. All good? Exactly like the ones off your homework. Here we go. So it says, find sine of 2 theta, cosine 2 theta, tangent 2 theta, if cosine of theta is 5 pi thirds, and we're on an interval from 3 pi halves to 2 pi. So think about where that is. So here's 3 pi halves, and here's 2 pi. So they're telling us where to draw our triangle, because isn't that what we're dealing with here? Yeah. A triangle. So it must be over here if it's on that interval. So our theta's right there. There's our right triangle. Okay. So cosine is adjacent over hypotenuse, isn't it? So adjacent would be here, so that's 5, and hypotenuse is 13. So that's making sense. Positive, positive, because hypotenuse is always, we're going to write the hypotenuse always positive. If you remember back to these. Because of this information right here. Theta is between 3 pi halves and 2 pi. So we knew it was in that quadrant. Yeah, absolutely. So now we can do Pythagorean theorem. We would do 13 squared minus 5 squared equals the y value squared, which will come out to be, if you simplify that, 12. So this is 12. So now we can find sine of 2u. So now this isn't just sine of theta, it's sine of 2u. So what we're going to do is we're going to say sine of 2 theta will be 2 sine of theta cosine of theta. Because we're dealing with just theta. So if you rewrite it like this, now we can answer what sine of 2 theta is. Because we know what sine of theta is. So this is 2. What's sine of theta? Sine is opposite over hypotenuse. So wouldn't that be 12 over 13? Yeah. So that is 12 over 13. So it's 2 times 12 over 13 times cosine of theta, which is 5 over 13, adjacent over hypotenuse. And now it's literally just simplifying it. So sine of 2 theta simplifies to be negative, wait a minute. This is negative though right here, right? Because it's in the quadrant. So I need to hurry and fix that. So it's going to be negative 120 over 169. It's the simplified fraction. Okay, I'll give myself some room. Now we can solve, okay, let's do cosine. So cosine of 2 theta equals, we can use really anything for cosine. You know how there's 3 different ones? I'm just choosing to use this one because I know sine. Everybody, I mean, we can use any of them, really. Do you get what I'm saying? Yeah. Oh, I just was like saying I'm rewriting it as these two things. I was just crossing out to make sure I didn't miss anything, sorry. Like you get that sine of theta is this?
Oh, then you like
yeah, then you just straight up multiply them. Yeah. So cosine of 2 theta, we've got it, it's not 2 theta, it's just theta, so we've got to write it like this. So that's 1 minus 2 sine squared of theta. So now it's just algebra, literally. 1 minus 2, and then sine of theta is opposite over hypotenuse, isn't it? So then sine squared theta, we'll write what it actually is, which is negative 12 over 13 squared. So you'll just do this in your calculator, math enter, and our simplified fraction is negative 119 over 169. So it's just algebra once you've gotten it in terms of just theta instead of 2 theta. Yeah, remember these were the things that I gave you as the formulas, and cosine had a few of them, but I just chose to use that one, but you could have used any of them for cosine. No, it doesn't matter, because we can find tangent, we can find cosine, so it doesn't matter. Yeah, you could have done that instead, because then you would have just used the appropriate trig. The appropriate cosine is adjacent over hypotenuse. Okay, now let's do tangent of 2u. So we want it tangent of theta. So we would say tangent. So tangent of 2 theta is the same thing as 2 tangent of theta over 1 minus tangent squared theta. And we can find tangent of theta. So now it's just algebra. So tangent of 2 theta equals 2 times tangent of theta, which tangent is opposite over adjacent, isn't it? So 2 times negative 12 over 5, opposite over adjacent, divided by 1 minus tangent, which is negative 12 over 5 squared. And now you'll just use algebra, but correct algebra, keep in mind. So let's make sure you can type that in and get it right. It should come out to be positive 120 over 119. So maybe hurry and take a second and see if you can type that in correctly. I'll push pause and give you a second. The instructions out of the book for this one are, as it says, derive the triple angle, because we just did double angle, right? Double angle. It says derive the triple angle formula. So basically what we're dealing with here is just saying to ourselves, we want this all in terms of x, not 3x, not 2x, not just x, because then it's easier to simplify or solve it, right? If it's just sine of x. So you would rewrite sine of 3x as sine of 2x plus x. Why did I do that? Because I know the double angle formula. And then x is pretty. Sine of, yeah, you could, yeah. Yes. No, I get your question. I'm trying to think. I'm kind of mind blank right now on that. Yeah, you could. Smart. So that is exactly what it is. We learned last time about the addition formulas and how to rewrite this. Thank you. That's exactly what we've got to do. So now we've got to split this up. So remember that sine of something plus something can be split apart and rewritten, right? So we would have, this is applying two things at once. So this is sine of 2x, and then cosine, so remember sine's on the outskirts of town, and that's what Sarah hates me to say. So we have sine of 2x cosine of x. The sign stays the same, plus cosine of 2x, right? Remember cosine's on the inskirts of town, it's the inappropriate one. And then sine of x. That's how we do it. Way to think of that. Okay, awesome. So now we would say to ourselves, we need it all in terms of cosine or sine. Let's get it all in terms of, I don't know, sine. Yeah. So we can rewrite this as what? So that's 2 sine of x, right? 2 sine of x, cosine of x, and then we have times cosine of x. Because this is a double angle formula, which became that. Plus, and then we have our double angle formula for that. So what's that piece going to become? Let's make it in terms of sine, because there was 3 of them. Let's make it in terms of sine. So 1 minus 2 sine squared x, and then we have times, so that's in parentheses, because it's cosine of 2x times sine of x, so times sine of x. Yes. Yeah, because this is literally the same thing as this. So do you see how we're just rewriting it? Yeah. Like instead of that, we have that, because they're equal. Yeah, but this is one of the formulas we got today. If you look back to your formulas. Yeah. Good questions. Really good question. So that was a new formula we got today. This is equal. So now we would distribute sine through, ding, ding. So what we're looking at is 2 sine of x cosine squared x. Cosine times cosine. Plus sine of x minus 2 sine cubed x. Very good, Dylan. So now let's combine like terms. What's cosine squared x the equivalent to? We want it all in terms of sine. So we're going 2 sine of x times, instead of that, 1 minus sine squared x plus sine of x minus 2 sine cubed x. We changed cosine in terms of sine, so we wanted it all in terms of sine. So now we would distribute that through. So that gives me 2 sine of x from this piece, and then minus 2 sine cubed x. And then we have plus sine of x minus 2 sine cubed x. So now we've fixed it so it's all in terms of sine. So now we can combine like terms. So this one did take a lot of thought. Good. 2 sines of x plus 1 sines of x is 3 sines of x's. Minus 4 sine cubed of x. And we're golden. And now we fixed it so it's all in terms of just x, not 2 x's, not 3 x's, and it's all in terms of sine. Yeah, that's all we were doing. We could now factor it and keep going, but we're not solving it, so it just said derive it. So yeah, if we were solving it from here, we would then factor it and then continue to see if we could solve it. Good point. Okay, last thing, and there's only two more examples. 2 more. Last 2 examples. Write down the half angle formula so when you go home on your homework, you can do it. So we just learned double angle formulas. Now here are the half angle formulas. Which these ones aren't bad. Neither are the double. So sine of u over 2 is equal to, be quick about writing these down because we got to get going. Okay, notice how it says, okay, multitask as you're writing them down. Notice how it says sine of, and there's technically parentheses here, so sine sine of u over 2 can be rewritten as, that's a problem. We always want it just as u or just as x, not 2x, not as x divided by 2. So that's the point of these. So it's plus or minus, but here's the thing. It's not going to be plus or minus. It's going to be plus depending on the quadrant. So sine is our x value. So depending on the quadrant, you'll put a plus or a minus in front. Does everybody get what I'm saying? So if, yes. Yep. So it just all depends. We'll get an example where we have to decide. Then cosine plus or minus, and tangent is just 1 minus cosine of u divided by sine of u, or sine of u divided by 1 plus cosine of u. You can use either. So once again, why are these prettier? Because it's not u divided by 2, it's simply u. Simply u. Simply u. Why are they? That's better because it just. Okay, last 2 examples. Are we good with those? Need more time? 5, 4, 3, 2, 1. Okay. It says find the exact value of sine of 105 degrees. Is that on our unit circle? No, it's not. So you have to say, well, how am I able to find the exact value if it's not on my unit circle? It must have something to do with something that's similar. Well, isn't that half of 210?
Yeah.
Which is on our unit circle, right?
Well, that's what we use a half.
Yeah, that's when you use a half. So what we're really looking at here, guys, is sine of 210 degrees divided by 2. Isn't this the same thing as that?
Yeah.
So it's a double, it's a half angle, I'm sorry. So we would say this is the same thing as, so sine of 210 divided by 2 equals, now where is 210 fall on my unit circle? Isn't it going to be down here somewhere? Yep, so it's going to be over here, so 210 degrees. So that's negative x, negative y. Sine is y, right? So we're going to use negative square root of 1 minus cosine of 210 degrees divided by 2. Now, why is that nice? Because that's on our unit circle. So we're really looking at negative square root of 1 minus, what's the cosine at negative 210? Find your unit circle and look real quick. Negative root 3 over 2. You guys see what I mean? I just looked at my unit circle and rewrote what that is. Okay, yeah. Yeah. So just a reminder, we decided to go with negative because sine is y values. And in this, it's negative x, negative y. So that's why we used negative. And then I'm just plugging it in now because it's just algebra. Uh-huh. Yep, so I'm sorry, I need to keep writing this. I just was pausing. Yep. So now we need to simplify it. Yep. And that was nice just because I was on our unit circle. So we have is equal to negative square root of, right here, we're going to want to get a common denominator. And won't that be technically 1 plus root 3 over 2, because minusing a negative. So this is over 1, right? I'm just going to get a common denominator, multiply by 2 over 2. So what we have on top is technically 2 plus root 3 all over 2, isn't it not? Doesn't that top, do you guys get what I'm saying? And then that's divided by 2. So that's really divided by 2 over 1. And that's all under the radical. So dividing fractions is easy as pie. You flip the second and multiply. So are we really dealing with the square root, negative square root of 2 plus root 3 divided by 4. So now you say to yourself, can that continue to simplify? Well, yeah, we can split it up. 2 plus root 3 divided by root 4, which is, because now I can split it up, right? Can't I? As long as they're both still left under the radical. So we were simplifying this right here.
Yeah.
So on the top, we focused for a second and got a common denominator to get us here. And then dividing fractions is easy as pi. We flip the second and multiply.
So it's not all of the
Yes. Yeah, this should extend clear down. So then we have, our answer is negative square root of 2 plus root 3, which doesn't go any further, divided by the square root of 4 is 2. So that would be our exact answer. So we were able to find an exact answer even though it wasn't on our unit circle. Because that's the exact answer of technically 105, isn't it? Sine of 105. So our sine of 105, we were able to still find an exact answer because we were able to manipulate it and rewrite it so that it was on our unit circle. So sine at 105 degrees equals that, bad boys. And you could even check it. You could type in sine of 105, you'll get the decimal, and then you'll type that in and get the decimal, and they should be the same decimal. Let's make sure. Because for some reason I don't have a negative listed in here. So, sine of 105. Is it negative? Please tell me it is. It came out positive? So where do we mess up? Sine x, sine 1. Yeah, you got negative. Okay, I trust her. Oh. It's not negative? Oh, crap. What I did on accident was it's really 105. Which quadrant is that in? Right, it's 105. My bad. 105, so it was in quadrant 2. No, because it's negative x positive y. Sine is y. So we would put a positive. Sorry, that's what's going on. But we're good, right? Yeah. Yeah. So you got the same decimal, didn't you? Cool. Okay, last example. It says find all of the solutions. So last one, we got to get through this one in the next 10 minutes, which we can. So it says find all the solutions on this interval. So notice, because the only reason we have a problem here is because this is x over 2, which is an issue. Because it's not just simply x. So you'd say, oh, this is a half angle formula one. So let's rewrite it. 2 minus sine squared x equals 2. And then what is cosine squared of x over 2? Well, we can think of this as, better yet, think of it as this. Cosine of x over 2 all squared. Because this means the same thing as that. You can write the squared out here or in here. Does everybody understand they're the same thing? Remember how we talked about if I wrote sine squared x is the same thing as sine of x all squared? Same thing, right? Okay, so what we're looking at is this. Now you can rewrite this as that, can't we? Because it's a half. Look, isn't that literally equal to that? So we have 2 minus sine squared x equals 2, and then instead of cosine of x over 2, we have plus or minus the root of 1 plus cosine of x all over 2, and then isn't that squared? So I just rewrote that piece as what it's equal to, that. So that's 2 minus sine squared x equals, well, isn't a positive and a negative squared always positive, first of all? Yeah. So those won't matter because they're squared. And then root and power, don't they cancel out? Yeah. So we have 2 times what's left over, 1 plus cosine of x all over 2, don't we? Good, those 2's divided out. So we're dealing with 2 minus sine squared x equals 1 plus cosine of x. We're trying to solve it. So we solved these now. Now, what was our goal? We were trying to get it all in x terms, and we do have that. So now we just solve it like normal. You'd say, I've got to have just sines or cosines or something. So can I change that to cosine? Right? Because we can't change that. It's stuck. So 2 minus 1 minus cosine squared x, I rewrote that, equals 1 plus cosine of x. And now we'll solve. So that's 2, distribute the negative. minus 1 plus cosine squared x equals 1 plus cosine of x. And now we're going to get it set equal to 0.
What was that? My square root.
That was a trig identity.
Oh.
Good question. So we use our trig identities to rewrite sine squared as 1 minus cosine squared x, just because we couldn't change cosine, so we needed to put it in terms of cosine. So now let's combine like terms. Subtract 1, subtract 1. So isn't that 2 minus 2?
Yeah.
So that's gone. So we have cosine squared x equals cosine of x. So we have cosine squared x minus cosine of x equals 0, because I subtracted cosine. And now we can solve by factoring. Factor out cosine x. Left is cosine x minus 1. And now we can set each of those equal to 0. So we want to know when does cosine of x equal 0 and when does cosine of x equal 1. Because I just set each of those equal to 0 and solve. So our answers for when does cosine equal 0. Yeah, pi halves and 3 pi halves. There's our two solutions. X equals x equals.
Wait, did this say like
Yep, on an interval from 0 to 2 pi. And then also cosine of x equals 1 at over 1 up 0, isn't it? So isn't it at 0?
Yeah.
So our other answer is x equals 0. 2 pi actually is the repeat of 0, so it doesn't include it. So that's why they always say on an interval like this, from 0 to 2 pi, they do a bracket and then a parenthesis because the 2 pi isn't included. Good question. So we would write it as 0, because that's the one that comes first. So those are our solutions. They're not bad, but I get that it's a lot to think about. All right, so a lot of these are just super straightforward, just like drawing the triangle, you know, the one. So it's not too bad. All right, that's it.